Welcome to Women Who Code San Francisco chapter Backend Study Group event. We'll start in a moment. We are recording tonight's event. We may plan to take screenshots for social media. If you're comfortable, turn the video on. If you want to be anonymous, then turn the video off. We will make some time for Q&A at the end of the presentation. Feel free to take notes. Online even best practices. Don't multitask. Distractions reduces your ability to remember concepts. Mute yourself when you are not talking. We want the session to be interactive. Use the raise hand feature to ask questions. By attending our events, you agree to comply with the code of conduct. So for the introduction, my name is Anjali Bajaj. I am the co-host and I'm the co-host for this session, as well as we lead at Women Who Code San Francisco chapter. And welcome to Women Who Code event. Our mission is to empower women to excel in technology careers. At Backend Study Group, we learn and discuss backend engineering concepts. Prachi is the instructor for today's session, and she's also senior software engineer at Unity Software. Now over to Prachi for the agenda.
Thanks, Anjali. Hey, everyone. Welcome to another session of Backend Study Group. We started a few years ago, and we do sessions very regularly around concepts of backend engineering and computer science. Today's session is about how to be a good backend engineer. A lot of folks ask me about doing a session around this, so here we are. We will go through what the role is, what the skills are required, what technology stacks do backend engineers usually use, what does a career path look like, and we'll do Q&A at the end. But if you have any questions, you can feel free to put them in the chat and we'll address it towards the end. So backend engineering, right? Very quickly, backend engineering is where we design, build, and maintain server-side web applications. We'll look more into that in a bit. Some of the concepts that we care about or we need to know in backend engineering is about client-server architecture, networking, APIs, web fundamentals, microservices, databases, security, privacy, operating systems. There's a lot more. A very common technology stack for backend engineering would be languages like PHP, Java, frameworks like .NET, C#, Ruby, Python, and so forth. If you look at the diagram, everything that's dotted in red is all behind the scenes, which a end user doesn't see in the browser or the phone. And all the logic behind the scenes and applications and servers and database, all of that is considered backend. So who is the backend engineer, right? When you study computer science and get in the tech industry, it's a huge domain, and there are very different roles that are there in the technology industry, like a front-end developer, a full-stack developer, a back-end developer, DevOps engineer. There are a lot of roles. Today, we are only going to focus on back-end engineer, or back-end developer, or server-side engineer. I'm not going to focus on other roles, and I'm not even going to talk about the difference because that is not relevant for this session. If you guys are interested in the career path and differences between different roles, let us know and I can work on a session for that. Backend engineer, we typically care about server-side development. It's all backend, right? We focus on how the website works, any updates, any changes. It can be a website, it can be a web application, it can be a software, but we care about how it works, how it's supposed to maintain, how it's supposed to develop. All of that is backend engineering, core functionality. We care about the functionality, the logic behind the scenes, what powers a software or a website or a mobile app, right? We care about all of that. We build robust and scalable systems, handle huge data, and ensure everything on the client side actually works. Like when you hit a website, Amazon.com or Reddit.com, right? You see everything works fine. You see all the different sections. You see all the relevant data. But how is that rendered, right? That's just your front end or your experience. But the decision making around how that will look like and how the data is rendered and what is the user experience, a lot of it is also decided or determined on the backend side, behind the scenes. We work on creating libraries. We write APIs. We work on different system components. This can be like inter-service communication, communication between different systems or different applications. We ensure that all the different components or modules of a system interact properly, the data flow and the logic flow is correct, and we also care about data and database management. It can be as simple as creating a database, creating tables, and then manipulating that data as well. All of that would be backend engineering. And business logic and domain-specific implementation matters, right? Like if you're creating a portfolio management software, well, you need to understand what does a portfolio mean. You need to understand a thing or two about like stocks. You need to understand, like you need to have some basic financial knowledge, right? Or investment knowledge. So that is your business logic, or that is your domain-specific knowledge or implementation that you need to understand. And you need to develop those business requirements into code. That is what backend engineers do. And domain here can be like financial technology, it can be insurance, it can be shopping, it can be retail, it can be something like, Macy's.com, right? The domain is e-commerce or retail. So we need to understand what that looks like. A little bit more, if I drill down into details and specifics of all the things that backend engineers know or they do, well, there's a lot. It's backend engineers, like they need to know a lot of things, and they need to take care of a lot of things, even for the day-to-day work and understanding. Basically, backend engineers specialize in designing, implementing, and maintaining server, database, application logic that powers the front end or user-facing components of a system, right? You can have a mobile app, but behind the scenes, there is some kind of software or application that a backend engineers developed. You can have a tablet app, but behind the scenes, there is like a application software, right, that a backend engineer has developed, right? So backend engineers, whatever your front end or user experiences, backend engineers take care of all the behind the scenes implementation. Database management is extremely important. You can design, implement, and manage databases, SQL databases, NoSQL databases. You can determine what the data format looks like. You can define a schema. You can define how often the data is manipulated. You can define what the data actually looks like, what you want to store, what you don't want to store, what the security and privacy around your data collection looks like. All of those decisions are made by backend engineers. Like I said, we're creating schemas, we write SQL queries, we run SQL queries, we optimize database performance, we ensure data integrity is in place. All the principles of database creation and manipulation are all need to be followed. And backend engineers have this knowledge, and they implement, they work on it like in the day-to-day. An example would be implement a relational database using PostgreSQL to store user profiles for a social networking site, right? Like this is your requirement. Now you need to go and understand like Postgres, or should I use some MySQL or something, or Oracle, right? I would also want to make that decision as a backend engineer, and what the trade-offs are. Should it be a relational database or a different kind of database, non-relational data? I need to make that decision as a backend engineer. Keeping different trade-offs in mind. And then how do we store user profile? What do you even mean by a user? What data do I need to collect for the user, right? Like all of that is what backend engineers are working on. They will do the design, they will understand the trade-offs, and they will make recommendations. And they are the architects as well of the applications. Server-side logic, right? Server-side is like a common term, like client-side is your front end and server-side is everything back-end. So it's a very common term. Server-side logic is, writing logic that processes user requests, right? Interacts with database, different components of the system, getting data from the front end or client, and then responding back, right? You get some data, you collect some data from your website, from the user, you do some manipulation around it, and you return a response, right? All of that flow, the API contract, that whole interaction is all something that backend engineers design and implement. Right? So example would be like developing a logic to handle user authentication. When a user submits a username and a password, when they're trying to sign into their account on a website, you need to make sure that it's the correct user, the password username is correct, they have the right privileges, the authentication authorization needs are taken care of, they have the right grants. If the user does not exist, or the password is incorrect, or username is incorrect, what kind of errors do you want to show them? Right? Like if password is incorrect, you can't tell them, hey, your username is wrong. You have to tell them that the password is wrong and you need to fix it. So all of that implementation, all these small details, decision making is what backend engineers do. API development. API is application programming interface. It basically is one of the ways different services communicate. Also, front and back end communicates using APIs. We need to design and develop APIs and what those contracts look like between a front end and a back end. Right. This will allow different systems or software components to communicate, and it will also help us manipulate data and enable features and functionality. For example, we want to design a RESTful API that allows a mobile application to fetch user data from a server, right? Like right now, what we're trying to do is a mobile application front end wants to get some data from the server or the back end, and this communication contract is in the form of an API and a RESTful API. So now we need to understand what REST is, what RESTful APIs mean, what are the best practices on designing an API? Are you following those a backend engineer knows this. Like you can interview them anytime and they'll just tell you right away. Like we just know this, right? These are basic foundations for us, and these are best practices. We just know it. So whenever, if I get a requirement from my team that we need to design an API, like I already know the best practices. I just need to make sure that how I can implement them in the context of my application or the requirement. But I already know what an API is. I know what RESTful is, and I can. I know the best practices. I can code an API easily. I just need to make sure that fits the technical requirements and the business requirements align. This is all day-to-day for backend engineers, basically. Integration. So integration is it's a key component. A good backend engineer is good at integration. Okay, they understand different APIs, they understand different versioning, they understand API contracts and inter-service communication. The integration basically means you communicate between different systems and different servers to ensure smooth flow of data and logic. It can be systems in the back end that communicate with each other, integrate with each other. It can be front and back end, it can be even between different devices, right? Like communication from like a tablet. If I want to transfer something from my phone to my MacBook, right? Like there is some kind of communication established between these two devices. As a backend engineer, I would look into what that looks like, or that is some integration that I would want to work on, or I would work on. One example is like integrating like a payment gateway, right? When you go to like a store, or even online, when you're buying something, when you submit your credit card information, what happens? You're temporarily taken into this Stripe gateway, payment gateway that checks for your credit card, make sure that you have the right balance, make sure your information entered is correct, and the credit card is valid, and then the payment went through. So Stripe handles all of that. So that is the integration from your website to Stripe. And then once Stripe takes care of everything, it returns a response. And then on your original website, you get a response that, hey, payment went through, order is confirmed, here is the tracking information, here is the details of the order, hey, now you can download your receipt. All of that is backend implementation functionality, but of the core website or your e-commerce core website, but you were integrated temporarily to Stripe, which is a completely different company, completely different product. And then that took care of payment functionality. And then you're back to your prime site. So this is an integration that this is between two different companies, two different products entirely, right? Not within a company. So that is something that good backend engineers can do. One example would be like I did a hackathon where one of our colleagues had a Tesla car, and we just like spent a day figuring out the Tesla APIs, and we wrote a whole backend integration calling the Tesla API with the correct authorization. And our colleague would drive the car, and we would see the live stats of their car information and ride information. And we created a mobile app to display this data in a nice visualization way, right? So we did this whole integration with Tesla API, and then even in a front end mobile app, you were able to show like nice charts and nice data, just to prove an integration, like how quickly we can do it. So that is one good example as well. Performance optimization. Every good backend engineer cares about efficiency, automation, performance optimizations, and costs, right? Like wherever in applications, in your systems, there are opportunities to improve your performance, right? Save costs, save time, automate a few things that are taking longer if there is an option. All of that is something we care about. When we are architecting and building some things, an application, let's say this is already considered on day one. And then we can make a choice. Hey, we are only improve like XYZ performance. Then we'll launch something and we'll see how the product performs, and based on that we will do some more performance improvements later on. But performance optimizations, automation improvements is something we always think about, and whenever we get an opportunity we want to make those improvements in our application, in our system, data flow, logic flow, everything. Even code improvement, implement best practices that can promote improved performance. So you always have that in mind. For example, you want to implement Redis like caching to speed up data retrieval, so data reads from your databases, right? That's a performance improvement, because database reads are expensive, but if you implement like a cache layer and use Redis, for example, for caching, and you know what the data is, and you know how many times to fetch, and if you understand the Redis architecture, you can fully implement a cache, key value store, and do your reads from your front end in your Redis cache or Redis database instead of like an actual database read, which is time consuming and even more expensive. So this is an improvement that you can absolutely do. And these are some of the things you might do when you're architecting an application. You're designing it before you even start execution, or this is something that you realize that, you know, our data is growing, we have more reads, our software is growing, we have more features, then this is something that we can improve, and you can have a reasoning around it, and this will save us time, this will save us money, this will optimize our system. So great, you can then do that as well. Security, never to be ignored. Right, like security and privacy, we want to ensure good security measures, compliance, privacy requirements are taken care of, right? If you are a website that collects sensitive information, you need to make sure that you either don't store it anywhere, your application is designed in a way that you don't store it anywhere, or if you do, it should be masked. You cannot store someone, if you collect someone's SSN on your website or app, you cannot store someone's SSN directly. There is like it's a PII, that is like major compliance security problem. Companies can get sued for doing stuff like that. So you want to, you need to understand how sensitive your data is. You need to make sure that you need to make a decision as to how much data you're collecting and what data you're not collecting, and how you are storing the data and how you're reading from it, and who has the permissions to read that kind of data. So all of those decisions backend engineers are doing when they look at like the database implementation or design phase. This is something we also care about. And this can also be your application logic, right? Like depending on your application or website, certain information you don't need to collect, right? So why would you do it? Right? If I go on Amazon.com and I'm putting my order and I'm adding my credit card info and shipping info, well, they don't need my SSN. So why would they ask for that, right? So they should not do it. So it's a very simple example, but like backend engineers decide what data to collect, how to store them, what data not to collect. They make sure that compliance needs are taken care of, and security, privacy, best practices and standards are followed. It can be something like we use this tool because it's more secure for storing database, right? Or we use an XYZ kind of an application for monitoring because it gives us more data about our application, and we are more confident about our security and privacy needs. So what is your security need? What is your privacy need? What are your compliance needs? All of these things backend engineers care about. And this is, again, when you're designing an application or architecting an application, this is something that's obviously considered. For example, right, like setting up a secure HTTP connection for a website, setting up basic data encryptions, guarding against SQL ingestion attacks, something you need to obviously know about. You need to know what SQL injection is. You need to know some basic data encryption algorithms. You need to understand the basics of HTTP connections for a website, and you implement that. So this is, again, basics for the backend engineer. Infrastructure and deployment, right? You build an application, but you're deploying it somewhere. You're maintaining it. It's built to maintain for years, right? And as your data grows, your application grows, and you add more features. Your application grows, the amount of data you collect grows. Now you have like complicated systems and infrastructure in place. Infrastructure is basically a database or an application server, a web server, or a load balancer, or a caching system, or your monitoring system, or your pub sub queuing system. There's a lot that goes into infrastructure, right? So like or a cloud infrastructure in this example, right? Your CI/CD deployment pipelines. There's a lot, right? A lot of tools here. So you need to understand like what infrastructure you're using, how does that look like, how do you monitor your systems, if there's a downtime, what does that look like, and the impact on the user. And all of infrastructure also is related to like costs, right? Like these tools are very costly. So like I would use let's say honeycomb instead of like New Relic, or instead of SignalFX or something like that, right? Like for my logging, I need to like make those decisions as an engineer. This is more cost effective. This tool is better suited for our needs and for our application. Therefore, we'll go with this tool. And that is a recommendation me as a backend engineer can totally give. And make that decision. So we need to understand what the infrastructure needs are and what tools we want to use, and how would we integrate with these tools, right? Our system need to integrate with these tools. What does the licensing cost look like, and test the whole process out to then maintain our systems and our infrastructure and our SDLC processes as well. Backend engineering is exhaustive. It's there's a lot that goes into it, but once you get into backend engineering, you understand all of this is like a day-to-day for a backend engineer. We just know these things, and whenever we design, we architect, we build, we maintain software, we monitor. Like these are basics. We just know these things. Some of the skills that technical skills that are required for this role or for backend engineers, programming languages, right? Obviously. And these are server-side applications, so server-side programming languages like Java or your Python or Scala, because they solve a lot of problems around robustness, scalability, clean code, code extension. They follow object-oriented programming principles. So this really helps understand like the best practices around server-side application coding, and also a lot of these languages and frameworks solve some, like some common problems around authentication or security, or like database management or API integration. So some of the solutions are already there. So these languages and frameworks really help develop a better server-side application logic. Database management, right? I said, like creating and managing a database, right? SQL or NoSQL, to store, organize, manipulate, and fetch data efficiently. So it can be a SQL database, a NoSQL database like MongoDB or PostgreSQL or Oracle. You get to decide, right? Even caching mechanisms like Redis or Memcache would be slightly database side as well. It's infrastructure, but also database as well. So those decisions, those are some of the skills and examples of like tools or technology you want to use. API design and development, right? Like design a RESTful API and allow software components to communicate with each other. But you can also like run a curl command in your terminal and test out an integration, right? Like you also need to know that. Like this is again basics of CS or computer science, but that's something like if I want to understand what the Tesla API looks like, can I just do a curl command and see what I get, right? Instead of like writing a whole application and then calling the API and seeing like, I can just do a simple test, right? But I need to know what curl is, what are the limitations, how to like write a curl command, and how to use like commands in a terminal, right? Command line arguments and stuff like that. So that's something, again, as a backend engineer, I need to know. And again, it would be day to day. Understanding front-end technologies, right? Like you are creating applications, building features for like a front end, for like a client, for a user, to give them a certain kind of user experience, to collect data from the user in a certain way, right? So you need to understand what front-end developers are doing, what they're building, what UX designers are doing, what the requirements are there on that side, what technologies are used on front-end side, right? So backend engineers work, if you have a full stack team, again, backend engineers work very closely with front-end developers and UX engineers to understand what the requirements are and how do they design their APIs backend accordingly. If you don't work in a full stack team, you don't have a front-end product, everything is back office or backend, you're building for other systems, right? Then front-end component is not there, but again, there's always a feature, an API, something there that you are either like providing a service or you're collecting data, right? Or you're doing both. So there's always backend logic that we need to, or application logic and domain knowledge that we need to care about. Problem solving ability. debugging, bug fixing, researching in your code, maintaining code, all of that comes, right? Like you build an application software so you can maintain it, right? Building is one thing, maintaining is a whole different skill set, right? So you need to understand how to debug complex problems. You need to understand code that you may not have written, somebody else has written, right? You need to know how to identify and fix bugs. If you are given a feature to develop, like where do you start? What do you do? All the things you need to consider. So like problem solving ability is a must. Some of the other skills and technology stack would be around like version control systems, right? All your code needs to be version controlled. So you can revert back to a previous stable version, or you can get a history of all the changes that were made in your code, right? So you need to know how to use like Git or Substack or GitHub, right? Or GitLab, whatever tool your company decides. You need to understand how to use these systems, what the integration looks like, and basic Git commands, for example, is very good knowledge to have. And you need to understand like what version control is and what the systems actually do and how to make the most of it for your day-to-day. Even as a backend engineer, when you're working on stuff, you can improve your efficiency and you can get better with your processes if you know these systems and technologies. Security, already mentioned, right? Like code and data needs to be secure. You need to care about privacy and compliance, and it has to be maintained at all times, right? Because if there's a gap in how secure your application or data is, or privacy and compliance needs are not met, it can cause a lot of trouble, not only with the data you collect, but with your users, with your company, and it can actually cause legal issues. So we have to be very mindful of this requirement. Networking, like I said, right? Basic understanding of networking protocols, basic understanding of your operating systems, computer science fundamentals. All of this is rudimentary. It's fundamentals that backend engineers need to know about, because depending on the technology or tool or language you use, this knowledge will come in very handy. So this is foundational. Like operating system example would be, right? Like you are designing and creating a backend application, but it looks very different on a tablet versus like a mobile app versus like a computer on a website in a browser, right? So there might be small changes that you might need to do in your backend design, APIs, data storage, all of that to cater to all these different clients, right? So you need to have this understanding of like the operating system, some of the requirements, how do we develop applications for these kind of different devices. So that knowledge is, you can learn it as you're working on a project, but that's something you should care about as an engineer, as a backend engineer. Soft skills, right? Like, but at this point, you know, like backend engineering is like quite vast, and there are a lot of things that we backend engineers do on a day-to-day basis and are responsible for. So, you know, having good soft skills becomes important, especially when you work in like, if you're working by yourself, it's fine, you're good, but mostly we work in like teams, smaller to bigger teams, and communication and soft skills becomes very, very important, right? So project management skills, right? As a backend engineer, I need to determine what task I'm looking into, what is the scope of the task, what's the priority, what are the estimates, right? Can I finish this in 2 days, or I'm going to need like a week? Why, right? Like I need to be able to understand the task given at hand and be able to reason around it, right? Like, what am I doing? Why it's a priority? How much time it's going to take me? And what does the execution look like? I'm going to do 5 things here, which means if I do 5 things, then I'm going to call this task is complete. If I do 3 things, then I'm still in the middle of it and I need 2 more days to finish it. So I should be able to understand that very well. And this can be understanding technical requirements. This can be understanding product requirements. This can be understanding business needs. It's all included. If there's a requirement where I have to go and talk to someone in marketing team, I'm going to do that as a backend engineer. I'm going to be like, hey, who can I talk to? Hey, this is my requirement. Like, can you educate me on how this thing works? And I might work with marketing team, a product team together to understand what is going on. And then I'll implement a technical solution around it. And I should be totally able to do that. Team player, right? Like we have to collaborate with fellow engineers, PMs, people on the business side, non-engineers, to understand what problem we are solving, what new idea we are working on, what new feature we are developing, what does the solution look like, right? You need to talk to all these people, and everyone has to be on the same page as to what a backend engineer is doing and what changes and new features they're implementing and what the repercussions are. So when I'm working on a feature, like it's not someone else's responsibility to come and check with me. I have to make sure that I'm communicating and I'm making sure everyone is aware of what I'm doing and people feel confident. And that requires me to set up a meeting with someone for 30 minutes and tell them, hey, this is what I'm doing. These are all the changes. I just wanted to share with you. Do you have any questions? Do you have any comments? Are we good? Do you understand what's going on? Let me know. I'm here to help. Right? Like I should totally be able to do that as a backend engineer, especially if you're senior and beyond. Like this is kind of like expected. Patience. Backend development is much slower than front-end development. Things take time. We use a lot of tools and tech stacks. So like things can take time, systems take time to process. There can be glitches. Debugging, bug fixing can be tedious and it can be complicated. So front-end usually moves faster and backend is always like catching up. So like it's like if you take like a few days to solve something versus a few hours, it's like fine. It's like it happens depending on how complicated, of course, the problem is. But backend can be slower. It's complicated, and there's a lot to look into. So you need to develop patience. This is not very fast. So if you like fast-paced things, like backend is not ideal. Problem solving, right? Like you need to articulate the right problems to solve and the approach to debugging and problem solving and ideation and discussions around what the solution should be. Technical solution, it can be even a product solution. I worked in product teams in the past and we would come together. We were small teams, we would come together and engineers would give their input on what product decisions need to be made. Right? Because we are thinking long term. I'm not thinking what we need to do the next few months. We are like, what can we do today that will help us make our lives better in the next 3 years? That is something that totally we can talk about. And those discussions need to be encouraged. So you need to like have that problem solving ability. It's a skill to develop. Analytical thinking, right? Like tackle complicated technical problems. How do you gather requirements when there is very few, you have a knowledge of like very few things. Like my PM would come, a product manager would come and give me like a 1-line requirement. Hey, Prachi, we need to implement this. I'm like, okay, like I've not done this before. I don't even know who to talk to. I'm looking at the code and I don't understand things. I'm going to go around figuring out what does the code mean, what I need to implement, what is the requirement. I'll go reach out to 5 people if I need to and gather all the information and then be like, okay, this is the problem we are solving and this is my design and this is how I'm going to execute it, and this is when I'll be like, okay, we are done. So like with very few information, how can you go around gathering more information, identify the right technical problem and create a technical solution end to end around this. Attention to detail, right? Like backend, there are a lot of technologies and a lot of tools you use and you're looking at code all the time. You need to pay attention to like focus. You need to develop focus and you need to ensure that, you pay attention to the quality of code and the processes you're building so you can deliver high quality code that is maintainable and it lasts longer. That is like, again, expected. Technology stack, right? So like usually like if you look at the bullet points, they are very basic. That is like our day-to-day. Like I'm using an IDE for sure. I can use IntelliJ versus Eclipse versus Visual Studio. I use the IntelliJ and Visual Studio code both, right? So you IDs, like there was a time when you used to use Notepad and stuff like that. We don't do that anymore, right? IDs have made application development process fun and easier and faster. So you use some kind of integrated development environment, right? Like for example, IntelliJ IDEA is like the most common we use for developing, debugging Java applications. Database tools, right? Like you use SQL Workbench to write your queries, run them, see the performance, see the execution time, see all your data exported in a different view. The whole the tool is designed for you to do that. Or MongoDB Compass just to view like MongoDB data. So that's a good example. Postman, right? I need to test an API. I can either write curl commands, or I can just write like basically like code out an API calling a Postman, and I can just run it and test it, right? So API testing tools. There are also like testing tools for performance, API performance, and API monitoring, like Datadog, right? So those kind of tools also you need to know about and need to understand what the data looks like, visualization looks like, and what that means for the application and data. Version control, like I mentioned, right? Git, GitHub, Bitbucket, Stash, whatever your company uses or whatever you prefer. Even for personal development, like I have some personal projects, I use Git and GitHub for that, right? Like for my personal development. Even my own personal side project is like version control. So I need to understand Git and I need to make sure that like why I'm using it and why it benefits me as an engineer. Mean or Mon Stack, this is when you're doing like full stack development. You care about like your mean stack, where you care about like your back end, your front end, and your server and everything. If you're building websites and you care about full stack, then mean or Mon Stack, this is a good example of that. Now you need to understand MongoDB in this example, Express.js, Angular, React, and Node, right? How these technologies work together, what version are you using, what does the integration look like? All of that is something if you're using a dynamic web application, if you're building one or website, is something you need to understand. Ruby on Rails is another example, right? Like a lot of startups use this, like Rails platform to build and use Ruby programming languages to build your applications. Spring Boot is like convention over configuration framework, right? And that supports Spring and Java. So if you want to build microservices in Java and Spring Boot, like and Spring Boot is a perfect framework for you to do that, because it gives you out of the box a lot of like solutions around building like microservices, architecture and integration. Career path. Everyone starts with an entry level backend developer, backend engineer role. The title may look different depending on the company, but basically you'll be called a backend developer or backend engineer, right? Like you are not focused more on front end. You're not like writing something in Swift, right? Or you're not like developing for front end or mobile applications, right? But you are understanding how to write database queries. You're understanding like what does security look like. You are learning what the business logic or the domain knowledge is. You're learning how to write like APIs. You're learning how to build and maintain and deploy applications in production, how to test your code, right? What best practices are, how to fix a bug. Everything is what you're doing. Once you kind of like understand, once you've at least done a few of these things in a consistent basis, then you can become mid-level backend developer, right? Here, emphasis is more on your soft skills too. Like now you're working with other engineers, other teams, and expanding your skill set. You only do version control in Git, for example. You might do it in Stash or Bitbucket, or you'll use it in a tool that you never used, right? Like you want to improve your skill set and learn different tools, even different best practices, as well as different processes, right? So that's where mid-level engineer, that would be like more mid-level engineer, where you are this is where you become more like a wholesome engineer, backend engineer, right? Senior or a lead backend engineers, you are actually like overseeing not one project but multiple projects, different services. You care about front end, you understand that. You care about like the back end, you care about infrastructure, databases. You are making architectural decisions, right? Like we are starting a new application, right? Our company wants to launch a new product. For that, we need to build a whole new application, right? And these are the requirements, right? This is what our users want to see. Should I go with MySQL database or should I go with a SQL database, and why? Right? That is the kind of decision a backend engineer is making, and they will give the trade-offs and reasoning around it. So they make all sorts of architectural decisions. You might also end up writing like a whole full-fledged technical design doc, presenting it to different teams and stakeholders. You are leading these teams, you're leading this project, you're making sure that your team is on track, you're mentoring other engineers, you're working with people on the business, PM, data science side, and everything in between. And you are responsible for all of that. You might not even have a title of a lead engineer in this case, but if you're senior, you're expected to like do all of these things in your day-to-day. And as you get experience, you get better at these things. So it's like your normal day-to-day, but initially, it can be like, oh, wow, like this is a lot of work. Backend engineer, architect, or engineering manager, these are different paths. Architect would be like an individual contributor path, and engineering manager would be a management path or management track. After being a senior or a lead, you can divide, like you want to go management path or IC path, so you become an architect or a manager, right? So that's where the fork is. If you're an architect, you're designing even more complicated systems, not only for a team but for an entire company. Now you're looking at the entire company code base and all the infrastructure, and now you're making changes and improvements at that level, right? Like you know everything, you know all the teams, you know all the applications we have, all the processes we have, and that's where you are making improvements, right? And engineering manager would be like they manage people management, they manage engineering teams, right? And they care about stakeholders, they care about inter-team communication. They are not going to design or architect the application, but they will make sure that their architect, their lead, does the job correctly, and they are supported, and the team can deliver on time, and they care about the career progression of the engineers as well. Director of engineering or CTO, this is this is more like a strategic, right? Like you care about like overseeing engineering operations, you care about technology. One big difference between like an architect and a director of engineering or CTO is you care about like more strategic approach to what your product, like you're not thinking about, okay, we are going to do XYZ projects in the next 3 months. You care about like, hey, this is what we want to do in the next 2 years. How do we get there? What can we do today that this is the results we get in 2 years, right? Like how can we be more strategic? How can we prioritize our resources, our projects, and the technologies we use, the people we want to hire? Like you are looking into like all of that, and you're working with different leaders in your organization to make those technical or engineering decisions. And other big thing that CTO or director of engineering does is they care about innovation. They are like, hey, AI is a new technology, right? Like how can we use AI in our company, right? Like what are the processes we can automate? They will be responsible for like innovation, and they care about, they're at the top of all the technology advancements that are happening in the industry, right? And they care about understanding all of that and bringing the benefits of that to the company, right? Like a city would be like, hey, AI is very hot and new, ChatGPT has good APIs. How can we use those APIs to improve our processes or build a new feature, right? We build a new feature, we sell that new product, maybe we gain more customers. Like they are talking about that, right? So that is what their job is, like very future focused, very vision focused. So this is a career path. You can reach a backend architect level or engineering manager level in 10 years. You can reach in 20 years. You can reach in 5 years. You can reach in like 30 years. It depends on what company you work at, what technology skills stack or skill sets you have, how fast you want to go in your career. Do you even want to go at that level, right? Like when you're becoming a backend architect, you're not coding much. But when you're a senior backend developer, you're coding all the time. So if you are interested more in architecture and design and like distributed systems, high level systems, then you want to become an architect. But you love coding, you love what you do, then you just want to be a backend senior engineer for like 10 years. Why not? Because you love what you do. So there's nothing wrong if you are at the same role for years. It's all about like what you love to do, and these titles differ from company to company, so don't get discouraged by like a title. As long as you love what you do, whatever interests you in backend engineering, you are fine. So this is a usual career progression or career path if you pick backend engineering. So yeah, so we are at the end of the session. I hope this was helpful. Backend engineering seems daunting and complicated, but once you gain some experience, it's, to me at least, it was very fulfilling. I love what I do. So it's a very interesting role, ever changing. It's a lot of fun to solve like complicated technical problems. So I think it's a very good and stable career as well. So this is the end of the session. A little bit about us. We have more presentation. This presentation is on GitHub on our Women Who Code backend study group. So you can see all the presentations from our last 3 years on that GitHub page. In our repo, this event is recorded, so it will be available on the Women Who Code backend study group playlist. Anjali has shared all this information in the chat, so do refer to that. And we have more sessions coming up. This is the last session of this year, but we have like 3 more sessions already planned in the next year. So you can check out our meetup page and do RSVP. I hope to see you guys next year as well. And a little bit more about like Women Who Code if you're interested in joining our Slack channel, our mailing list, our events, our job portal. Feel free to do that. If you have any questions, you can just unmute and ask, or you can mention them in the chat. I think we're good. I'm gonna stop recording.